Okay, this worksheet is all about graphing radical equations. I'm going to go a little out of order because I want to start with what the parent function is. So our parent function is kind of like the one that we always, make all of our transformations based on. So if I wanted to graph this, y equals the square root of x, what would be some good values that we could plug in to get even or, no decimals, no fractions, answers out? Well, if I plug in 0, the square root of 0 is 0. What's another perfect square that I could plug in? If I plugged in 1, the square root of 1 is 1. Another perfect square I could plug in is 4. If I take the square root of 4, I get 2. And let's do one more point at least. Another perfect square is 9. If I take the square root of 9, I end up getting 3. So now I can just plot these points. 0, 0, 1, 1, 4, 2, and then 9 is just past that, and then over 3. So if I connect all these points, the square root graph is always going to continue in one direction, but it will have an end point. So this one stops at 0, 0, but goes all the way to positive infinity for my domain, and same thing for my x's, for my y's. It starts at 0, 0, and it goes all the way up to positive infinity for my y's. Okay, so we're going to take these values of x, and those are going to be kind of the values that we manipulate in order to plot our new square root function. Okay, so let's go back up to number 1. Okay, and you guys have been taught transformations before, so anytime you have something with the x, like in parentheses here, that's going to be a horizontal shift left or right, and it's always opposite of what you think. So this is actually going to be a horizontal shift left 4. Okay, so if I was thinking about my x, y values, normally we would plug in 0, 1, 4, and 9, because those are nice perfect squares, but I'm going to shift all of them left 4. So I'm going to subtract 4 from all of these to give me -4, -3, 0, and 5. So those are my new x values. Now for my new y values, I'm just going to plug these values in and evaluate it. So when I plug in -4, the square root of -4 plus 4, well, that's just 0. So I'm going to end up getting 0 out. If I plug in the square root of -3 plus 4, that gives me the square root of 1, which is just 1. If I plug in 0 here, 0 plus 4 is 4, so the square root of 4 is 2. And then if I plug in 5, 5 plus 4, square root of 9, that would give me 3. So now I can just plot these points, -4, 0, -3, 1, 0, 2, and 5, 3. So connect all those dots there and put an arrow on the side that you are continuing forever, okay? Looking at number 2. Number 2, I'm going to make my table here, x and y. Now for our x values, is there anything that's happening inside that square root? If no, then my x values are all going to stay the same of 0, 1, 4, and 9. Now my y values, this little +1 on the outside means that I am shifting all my y values up 1. So I can just go ahead and plug in 0 and evaluate this. So square root of 0 plus 1 is 1. The square root of 1 plus 1 would be 2. The square root of 4 plus 1 would be 2 plus 1, so that would be 3. And the square root of 9 plus 1 would be 3 plus 1, so that would be 4. Okay, so I can just plot these points, 0, 1, 1, 2, 4, 3, and then 9, 4. Plot your points just like so. Draw your arrow on the right there. Okay, number 3, x's and y's. So inside here, This x minus 4 means that my x values are going to shift to the right 4, and this plus 1 means I'm going to shift up 1. So normally my x values are 0, 1, 4, and 9, but I am going to add 4 to all of these to give me my new x values. Okay, and now to find my new y values, I'm just going to plug these x values here in red into my function and then evaluate it. So for the first one, the square root of 4 minus 4, well, that's 0. And then 0 plus 1 is 1. Change this to a 5. Square root of 5 minus 1, or sorry, 5 minus 4 is 1, and 1 plus 1 is 2. If I plug in 8, 8 minus 4 is 4. And then the square root of 4 is 2, so 2 plus 1 is 3. And then lastly, plug in 13. 13 minus 4 would be the square root of 9, and the square root of 9 is 3. 3 plus 1 is 4. So I can go ahead and plot these points here. 4, 1, 5, 2, 8, 3, and my last one's pretty far off there, so we're just going to leave it like this, moving up and over to the right. Number 4, I've got x's and y's. And looking at my equation here, this x plus 2 means I'm going to shift it horizontally 2. And then this minus 2 means I'm going to shift my function down at 2. So normally my x values are 0, 1, 4, and 9. I'm going to subtract 2 from all of these because I'm moving it left 2. And when I subtract 2, I end up with negative 2, negative 1, 2, and 7. And then to plug in, or to find my y values, I'm just going to plug my x values in. So negative 2 plus 2 minus 2. That first part would give me 0, and 0 minus 2 is negative 2. If I plug in a negative 1, negative 1 plus 2 is 1. The square root of 1 is 1. And then 1 minus 2 would be negative 1. Plug in positive 2. So 2 plus 2 there, that's 4. Square root of 4 is 2. 2 minus 2 is 0. And then last one, plug in 7. 7 plus 2, that's going to be square root of 9. So that would be 3 minus 2, which is 1. And now I can go ahead and plot these points, negative 2, negative 2, negative 1, 2, 0, and 7, 1. So now I can go ahead, connect to these points, and draw my arrow. Another thing I want you guys to kind of notice here, a pattern, is every time wherever your vertex is, it's always going the first point up 1 over 1. To get to the second point, it's up 2 and then over 4. And then to get to the third point, it's up 3 and over 9. And if you go back and check all these, that's how it is for every single one of these. Up 1 over 1 for the first point, up 2 over 4 for the second point, and then you would go up 3 and over 9 for the last point. If I go back up here, up 1 over 1, up 2 over 4, up 3 over 9. And lastly, that same pattern, up 1 over 1, up 2 over 4, up 3 over 9. It's going to continue that same pattern. All right, last one on this page here. I've got a 3 in front of it. So if I have a number in front, that means it's going to be a stretch of 3. So for my x and y's here, my x's are not being affected at all. So this is 0, 1, 4, and 9. My y values are what is going to be affected. So I am going to be multiplying my square root of x by 3. So square root of 0 is 0. 0 times 3 is 0. Square root of 1 times 3 is going to be 3. Square root of 4 is 2. 2 times 3 is 6. And then the square root of 9 is 3, and 3 times 3 is 9. Okay, so if I plot these points, 0, 0, 1, 3, 4, 6, 9, 9, somewhere up here. Okay, so now that pattern that I just showed you will not work for things that are being stretched, okay? Okay, so my stretched version will not follow that up 1 over 1 pattern, up 2 over 4 pattern, and up 3 over 9 pattern because we've got this number on the in front there. All right, moving on, page 2. All right, for number 7 here, if we pick our x and our y values, normally we pick the 0, 1, 4, and 9. Now, is there anything happening to the x? Is it being adjusted left or right at all? No, so these are in fact going to be our x values. And then to find our y values, we just got to plug in our x values. So 1/2 times the square root of 0, well, that's just going to be 0. If I instead plug in a 1, the square root of 1 is 1, so this would be 1/2. If I plug in 4, square root of 4 is 2. 2 times 1/2 is 1. And then if I plug in 9, the square root of 9 is 3. And then 3 times 1/2 is going to be 3/2. Okay, so when I plot these points, I got 0, 0, 1, 1/2, 4, 1, and then 9, 3/2. And then go ahead and connect your square root graph with your arrow on one side. Number 8, picking my x and y's again. X's are going to be your 0, 1, 4, and 9. There's nothing happening to my horizontal transformation there, so nothing is going to change for my x's. Now to find my y's, I just got to plug in my x value. So 2 times the square root of 0, well, the square root of 0 is 0, so this will be 0. If I plug in 1, the square root of 1 is 1. 2 times 1 is 2. Square root of 4 is 2, and 2 times 2 is 4. And then if I plug in 9, the square root of 9 is 3, and 3 times 2 is 6. So plot these points. And connect your square root graph with an arrow. All right, number 9, I've got y equals 3 times the square root of x minus 3. So for my x's and y's here, the x's we normally are going to pick is going to be 0, 1, 4, and 9. This minus 3 is going to be a horizontal shift right 3. So I'm going to add 3 to all of these numbers to give me 3, 4, 7, and 12. And this last one's going to be off our graph, so we're just going to ignore that one. To find my y values, I'm just going to plug in my new x values here. So I've got 3 times the square root of 3 minus 3. Well, that's just going to be the square root of 0, so this will be 0. If I plug in 4, I get 4 minus 3, which is 1. 3 times the square root of 1 is 3. Next one I'll try is 7. 7 minus 3 is 4. So 3 times the square root of 4, the square root of 4 is 2, so this would end up giving me 6. So I can plot these points. I was just shifted horizontal 3, and then I have a stretch of 3. So your square root curve looks something like that. Number 10, my x and y's. X's are going to be your normal 0, 1, 4, and 9. And then we've got to see what horizontal transformation is happening. So this plus 5 here is going to be a horizontal shift left 5. So that means I'm going to subtract 5 from all of these x values. And when I subtract 5, I end up getting a negative 5, negative 4, negative 1, and 4. So these are my new x values. Now to find my y values, I'm just going to plug in that new x value. So negative 5 plus 5 minus 3. Well, this part underneath the square root is going to end up giving me 0. So I've got 0 minus 3, so that's negative 3. If I change this to a negative 4, that would be the square root of 1. So this would be 2 minus 3, and 2 minus 3 is negative 1. If I plug in a negative 1, this would give me 2 times the square root of 4. So this part would actually give me 2, and 2 minus 3. Oh wait, I made a mistake somewhere. Oh, positive 1, sorry. Okay, and then the last one, if I plug in my positive 4, 4 plus 5 is 9, and then 2 times the square root of 9, that would be 6. So 6 minus 3 is 3. So now I can just plot these points. And connect my square root curve with an arrow on one side. All right, for these last two, go ahead and pause the video and test to see if your graph looks like what mine does. All right, you should have unpaused the video and your graph and work should look something similar to what I have here. Okay, on number 12, I'm gonna do the same thing. Go ahead and pause this video and then unpause it to see if you are correct. All right, and here is your last graph. Please let me know if you have any questions.